Okay, number 4, we have a combo circuit. So we have this, which is in series. The current all has to pass through this. When the current gets here, it's going to split. Some may go left and some may go right. It'll pass through these branches and come back together, so we have all the current again traveling this way and back to the battery. Okay. It turns out that we do know the total current this time, which is 4 amps. So that tells me that 4 amps has to cross through here. So I1 is 4 amps. Always look and see if you know what's going on with the current, because if you can figure out the current, it helps put everything else in perspective. Okay, so if I've got 4 amps coming this way, I2 is 3 amps. So if 3 out of 4 amps turns right, then 1 amp will turn left. Okay, and then the 3 and the 1 come back together here, come around, and so I4 is back to 4 amps. Okay, so that's the flow of current. That's important. Now I have 2 variables here, I have 2 variables here, I have 2 variables here, so there's 3 things I can figure out really quick. Now they're not asking me to find resistance on here, but I'm going to ask you to find everything, just because I want you to have the practice. So I can get the total resistance using this. So let's throw that little triangle up here again. So I equals V over R, so R is V over I. So 18 divided by 4 gives me 4.5 ohms. Okay, and resistor 1, again it's V over I, so 6 divided by 4 gives me 1.5 ohms. I can get this resistor, resistor 3, 3 divided by 1, 3 ohms. Okay, so I got those 3. Good, good, good. Now let's talk about what's going on here. Remember, this is in series, but this is in parallel. And when you have something in parallel, whatever the voltage is on one branch, you're going to have the same on the second branch. So if this is 3 volts, V2 also has 3 volts pushing electrons across here. So if I know V2, then I can figure out R2 with V over I again. 3 divided by 3 is 1 ohm. Okay. Current comes around 4 amps. What is V4? What is R4? Okay, let's talk about the voltage. That's going to be the easiest thing to get. The total voltage is equal to 6 volts plus 3 volts. We only add this one time, plus X, and that all equals 18. So, I found the sheet I'm looking for. Just FYI, remember we did this parallel, these notes in class, and I told you that the total voltage was 90 volts, and then we filled this in at each resistor. Okay, it's parallel, so the voltage is the same throughout. But notice I didn't add this 3 times, 90 times 3, and put down 270 here. It's 90 volts for each branch, and the battery is 90 volts. You have the same push across each. We're not losing any to a voltage drop. Okay, so here it's just one time. So the total voltage, which is, by the way, 18. Whoops, let me rewrite this, sorry. 18 volts is equal to 6 volts plus 3 volts, we only add it one time, plus X. So then X equals 18 volts minus 6 volts minus 3 volts. And that gives us 9 volts. So V4 is 9 volts. And if I know V4 and I4, I can divide those out. V over I equals R. So 9 divided by 4 gives me 2.25 ohms. Okay, so let's see. We can fill everything in here now. Let's see here. V2 is right here, 3 volts. V4 is 9 excuse me, 9 volts. I3 is 1 amp. I4 is all the way back up to 4 amps. But here's something that you can do to check your work. Okay, I want to make sure my resistors are all right. I want to get an equivalent resistance of 4.5 ohms. So to do that, remember, if you have a combo circuit, you got to figure out what's in series and what's in parallel. So this segment is in series. There's no choice. All the electrons have to flow through. These two are in parallel because the electrons have a choice. And then this one, no choice, it's back in series. So when you're figuring out the equivalent resistance on a combo circuit, you've got to get the equivalent resistance of just the parallel portion first. So I followed the parallel equation for equivalent resistance. So in my calculator, 1 divided by 3 plus 1 divided by 1, out of habit, equals this. I hit the inverse button, and the equivalent resistance for this portion
Amira Spike, if you're still in the building, please come to
is
Mr.
0.75.
Amira Spike.
That's just for this portion alone. Now it's just like we have an entire complete series circuit where we have R1, R2, and R3. And you just simply add them. And if we add these three together and it equals 4.5, I know everything here is good and solid. So I have my 1.5 plus the equivalent resistance of these two, which is 0.75, plus 2.25. And that gives me 4.5. So I've done a good job. The reason this works is we say that this parallel portion is set in series with the other two. Okay? Okay, so moving on to, that took longer than I expected. Let's do number 5, and I think we're going to make a third video. Sorry, talked too much. Okay, so current is 15 amps. I know how much current crossed branch 1, and I can figure out how much current crossed branch 2. Okay, so this is my total current. This is a parallel circuit, so the voltage is the same throughout. So I'm just going to go ahead and put that. I know that. The voltage is the same throughout. There's no series portion, so nothing to knock it down any. So, whoops, I don't mean to say V total here, but V1 and V2. Now I have 15 amps. They take off. 6 amps turn this way, so that leaves 9 amps to travel on. So I2 is 9 amps. You should be able to add your two currents and it should equal your total current. So VT is 120, V1 is 120, the voltage is the same throughout a parallel, the current is the same throughout a series. Voltage is the same throughout a parallel, current is the same throughout a series. It makes sense, there's only one loop in a series, but here the current has choices. So I2 is 9 amps, and now with our little handy dandy triangle, I'm looking for resistance, which is V over I. So R1 is 120 divided by 6, and R2 is 120 divided by 9, so that's about 13 1/3. And this is 120 divided by 15, which is about 8. Now, I wasn't asked to find this. They didn't ask me to, but I might ask you to, so make sure you know how to do that. And I can double check myself now. If I do 1 divided by 20, because this is parallel, plus 1 divided by 13 1/3, I'm just going to say a few 3's there, try to make it as accurate as I can, equals, and then I hit the inverse button, and I get very close to 8 ohms. So I did a good job. Okay, sorry, you're going to have to watch video 3. I'll try to make it short and sweet.